Good morning, children. We are going to take the lesson 3. What is this? Elements, compounds, and mixtures. We will see one by one what is the element, compound, and mixture. First one, look at the picture. You have elements, then you have the compounds, and you have the mixtures. First one, what is this? Elements, carbon, helium, oxygen. Then we have the compounds. What are the compounds here? Pure water, salt, sugar. And then we have the mixture. What is a mixture? Air, blood, milk. All these are examples for mixtures. Remember these small examples. Slowly we will learn what are the three types. One is the element, compound, and mixture individually. Okay. First one, what is a pure substance? Pure substance means it contains only one kind of atoms or molecules. There is no two types, only one type of or one kind of atoms or molecules. Okay. Now, these atoms or molecules will always be in fixed proportion. The proportion will not change. So, example, we have water and then a salt. It can be the daily salt which we use. Okay, so the two types of pure substances are elements and compounds. So what is a pure substance? It is a substance which is made up of same one kind of atoms or molecules, and they are in fixed proportion. Okay, what are the two types of pure substances? One is the element, other one is the compound. So what is the element? Element, we have examples as gold, carbon, oxygen, silver, aluminium. These are elements. Yes. So what is the element? It consists of only one kind of atoms. So only the same kind of atoms are combined. Example, we have copper, iron, calcium, oxygen, etc. Okay, so in total there are 118 elements. There are how many elements on earth? 118 elements. Of that, 98 elements are found naturally. Found naturally means they are found on earth. Yes, gold is found in earth. Similarly, carbon, it is also found in earth. Then there are 20 elements which are prepared in the laboratory, that is in the labs. Artificially we can prepare certain elements. So we have 20 elements like that. So totally we have 118 elements in our chemistry. So 118 elements, of which 98 elements are found naturally and 20 elements are prepared in the laboratories. So what is the examples for elements? We have hydrogen and we have oxygen. That is, they are made up of same kind of atoms. Hydrogen atom and one more hydrogen atom combined. Then they will form one element. Similarly, one oxygen atom and another oxygen atom, they will combine to form the molecule of oxygen. What are the characteristics of elements? They contain only one kind of atoms. They have its own unique properties, and then they exhibit the same properties as the element. That is, the properties will not change, and then they cannot be broken down by physical or chemical methods. We cannot break one hydrogen atom from the another hydrogen atom. Okay, so what are the characteristics? They are made up of same kind of atoms, then they have unique properties, then they exhibit the same properties as that of their element, and then they cannot be broken down into separate uh, elements. Okay, so these are the characteristics of the elements. Now we are going to see what is a new term called chemical symbol. Chemical symbol. Symbol means what? A small letter or a abbreviation. Abbreviation means short form. The short form or a abbreviation which we are going to use for representing a element. Say example, carbon. Every time we need not write CARBON. Okay, we will be using a short form or a symbol which is called C, capital C. Okay, so This is how we are going to use chemical symbols in chemistry, because every time we need not write the full name of the element, we will be using the chemical symbols. So in that case, earlier itself we had some pictorial representation, right? For say for oxygen, they will be saying like some pictorial representation in earlier times. Now then the later it was named after the place where it was found. Say it was named after the place because in that to honor the place where it was found, they were named after the place. Yes. And then in the modern times, the letters from the names of the elements are used. Now in the modern days, we are using the letter itself from the name of the element. Say C is from carbon, so carbon starts from C, so we use C as a symbol. Similarly for neon, neon means that is a gas, so neon, the symbols are taken from the name itself, the name of the element itself, so that it is easy to remember. Okay, so earlier the symbols, instead of symbols we were showing in the pictorial form, and then we moved to the naming from the place where it was found. Then we stopped all this. Now in the modern times we are taking the symbols from the name of the elements itself. So what is a symbol? It is a short form or the abbreviation, okay, of the elements. Okay. Now it modern times we are taking the letters from the names of the elements. Now how are we going to take the letters, or how we are going to um, give the symbols? Okay. There are three ways. First way is the can be taken from the first letter of the element. It can be taken from the first letter of the element. Simple example, you have O for oxygen, C for carbon. O is taken from oxygen, the first letter oxygen, and then C is the first letter for carbon. We take them as their symbols for oxygen and carbon respectively. Yes, and then we cannot say only one letter symbol. There are two letter symbols now. Why? Because say example carbon and we have calcium, we have cadmium, all are having the same letter C as the initial letter. So we cannot give C for all these names or all these elements. So what we will do, we will take the next letter. We will take the next letter. So first letter will always be in the capital. The second letter is the next non-repeating letter. Say now take the example of calcium and cadmium. First letter is C. They are repeating. Now look at the second letter. Second letter is also repeating. So first time for calcium we take Ca. Okay, so we take the first two letters, and for cadmium again we cannot take Ca, so we have to take Cd. Cd. Now if we take an example for cobalt, Cobalt, that is the full name of cobalt. So in the symbol for cobalt we can say capital C and small o, that is Co, first two letters. We first go with the first two letters. Now again if the second letter is repeating, then we go to the next letter. This is how we are going to give the symbols for the elements. And then we have certain names from Latin names, that is Latin words. They will take example as for potassium it is called as kalium, and for gold it is called aurum in Latin. So we will take the first two letters, or like the first letter you can take from the Latin names. Okay, so there are three ways to assign a symbol for an element. Either it can be the first letter of the name of the element, or then we go with the two letter forms. If the first letter is repeating itself, then we go to the non repeating letter and we take that as the second letter. Then we can derive some symbols from the Latin names. We have certain Latin names for certain elements. We can derive the symbols from the Latin names. Okay. So now we have some basic elements and symbols. First one is hydrogen. The first one is hydrogen, so H. Second one helium, He. Lithium. Third one is the lithium, Li. Fourth one is the beryllium, Be. Fifth one is the boron. Since we are giving B for boron, we have to find the next two letter symbol for beryllium. So that's why it came as Be. Then carbon C, nitrogen N. Okay, so you have to memorize this set of elements with the symbols, because this will be very useful in your higher standards. So children, you have to memorize this element list with the symbol list. This you have only 7 elements and 7 symbols. You can memorize this as like your tables. Okay, so that we can be asking questions on this. It will be easy for you to answer. Now, what are the elements with Latin names? We have discussed when we are discussing about the chemical symbol. So we can have the Latin names for certain elements like sodium, potassium, gold, silver, iron. So all this will have their own Latin names. So the symbols are taken from the Latin names. For sodium, you have natrium. For potassium, you have kalium. For gold, you have aurum. For silver, you have argentum. And then for iron, you have ferrum. Now, from here, I take the symbols. For from natrium, I take Na. From kalium, I take capital K. Then from aurum, Au. And for silver, again, I cannot take A, so I can take Ag. Then I have my iron, Fe, ferrum. So these symbols are not taken from the direct English name. We are taking it from the Latin names. So this list also you should remember. So this 7 elements with their symbols and this 5 elements with their Latin names and their symbols you should remember. So the first homework for today will be you should write these two things two times. These two ones, the elements and the symbols, and the elements and the Latin symbols alone for these 5 elements in your homework notebook. Now coming to compounds, we saw what is an element. Now we are going to see compound. Compound means two or more atoms. Yes, two or more atoms of same element or of different elements. Here we are going to say different elements. So the two or more atoms of different substances or different elements combine chemically. Chemically means through chemical methods in a fixed proportion. They are made up of molecules of the same kind. That means the molecules are repeating H2O, H2O, H2. So that will become a compound. Example, water and carbon dioxide. How is water formed? Two atoms of hydrogen and one atom of oxygen. Similarly, for carbon dioxide, one carbon atom and two oxygen atoms are combined. So this will form a compound. So what is a compound? When two or more atoms combine chemically in a fixed proportion. Then example, water, carbon dioxide. What are the characteristics of compounds? The same thing, two or more atoms combine, and then the properties are different. They're different from that of the constituents. The property of water is different from that of hydrogen and oxygen. Why? Hydrogen and oxygen are gases, whereas water is a liquid. So this itself shows the properties of the compound are different from that of the constituent elements, and they have their own physical and chemical properties, and they can be separated into individual components by chemical methods. We can separate them, hydrogen and oxygen, back to their element form by chemical methods. So what are the characteristics of the compounds? Two or more atoms combine in a fixed proportion. As the properties will differ, and then they have their own physical and chemical properties, and they can be separated into individual components by chemical methods. Now we are going to see what is chemical formula. Now the chemical formula again is a symbolic representation for compounds. Chemical symbol was for elements, whereas chemical formula is now for compounds. So simple compound we have carbon dioxide. How we are going to represent carbon dioxide? We already saw one atom of carbon and two atoms of oxygen are combined to form the carbon dioxide. And for magnesium oxide, we have one atom of magnesium, one atom of oxygen. And then for water, we have two atoms of hydrogen, one atom of oxygen. So see in the picture, I have shown blue color, two atoms of hydrogen, and the red color is the one atom of oxygen. They all combine to form a water molecule. So what is this water molecule? H2O. So this is the chemical formula, H2O. 2 is the number of atoms of hydrogen. So how many atoms are combined? And so we are writing that as a subscript. Subscript means one step below. H and O are in one level, means you write 2 one level below H. Okay, so that is where we are writing the chemical formula. How are we going to write the chemical formula, or what is the importance of the chemical formula? Mainly it gives the chemical name of the compound. Yes, chemical name. And then it will say what are the elements present. Yes, and then we can say the number of atoms, involved, and it is the one molecule of the compound. It will be representing only one molecule. There can be many molecules, but we are talking only about one molecule of that particular compound. Say example, we have carbon dioxide. What is the chemical name of the compound? Carbon dioxide. We can take it from the symbol itself or from the chemical formula itself. Carbon, C stands for carbon. O2, O2. O is for oxygen. 2 is for the number of atoms involved. So 2 comes as di. 2 means di, di. So di, and then what is that oxygen? So we are using that oxygen as oxide here. So what is the chemical name? From this formula we can take carbon dioxide. Now what are the elements present? One element is carbon, another element is oxygen. Now how many atoms are there? One atom of carbon and two atoms of oxygen. All these details can be obtained from one chemical formula. Yes, so once you look at a chemical formula, you have to understand this. So how are we going to name that? Then what are the elements involved? And then how many number of atoms are there? All these things you can gather the moment you see the chemical formula. Now we will see how to write a chemical formula. First, we should write the symbols for individual elements. I have told already, symbols are there for elements. So the moment you have find the elements, you have to write their symbols. Then you have to write the valency. This valency is a term which will you learn in the 8th standard. As of now, you understand the valency of each element has to be taken into consideration. Then we will interchange the valencies, and then we will be putting that in the subscript. Subscript means we will be writing one level below, and if there is a common factor, then we have to divide by the common factor. Then if the valency is 1, we will not write 1 every time. Okay, so now we will see how we are going to see the formula for calcium chloride. Calcium chloride. The moment you see the words calcium and chloride, you can say two elements are involved. What are the two elements? One is calcium, one is chlorine. So what are their respective symbols? Ca for calcium, Cl for chlorine. Ca for calcium, Cl for chlorine. Now what are the valencies? 2 is for calcium, 1 is for chlorine. The valency of calcium is 2 and valency of chlorine is 1. So you write Ca and Cl and then the corresponding valencies, then we cross multiply or we cross or we exchange or we interchange, whatever word we use, we are going to cross interchange the valencies. So now the valency of calcium will become 1, valency of chlorine will become 2. So that is where we are writing that in the subscript. Subscript means one level below. Since we have interchanged, now the valence of calcium is 1. We are not going to mention 1 there. So we are leaving it as it is. So it is CaCl2. So this is how we are going to arrive the formula for all the compounds. So you have to revise this or you have to do this homework and send it to me. Okay. Before that you should learn all the individual elements, that 7 individual elements with their symbols and then their Latin names and the symbols of the elements, that is 5 elements are there. And then you should work out this calcium chloride in your homework notebook. So 3 homework is there apart from the match which is in the last section. So you have to write these 3 homeworks and then the match one and you have to send it across. Yes, children, thank you.